Okay, now that we've gone through and written all of the equations for our story problems and we've gotten them approved by the teacher as being correct, because in the long run, if we solve an equation that was wrong to begin with, then we're going to have the wrong answer. So I must go through and do all of number 1 with you and all of number 6, and then you will have the remaining 4 problems to do on your own. If you're doing the online version, you'll see that it's broken up into part A, which was write the equation, part B, which was solve. So you would have to take a picture of your work and upload it into the document. You can upload 4 individual pieces of work, or you can just upload all 4 problems into one of them. As long as you've numbered them, I'll be able to figure it out. Part C, then, we're going to answer the question, and then D, we're going to go back to the function we were working with and come up with a domain. So, in number 1, just to refresh your memory, we had an object that was thrown upward with a velocity of 144 feet per second, and we wanted to know how long it would take it to hit the ground. So we took the formula they gave us and plugged in our velocity, and we plugged in the final height, which was hitting the ground, so 0. Now we're going to solve this. In order to solve a quadratic, it does have to be set equal to 0, and you would like it to be in standard form. So remember, standard form is ax squared plus bx plus c equals 0. So we have the equals 0 part, so we're good there. And our standard form is fine. Our a value is -16. Our b value is 144. And our c value is 0. Before we actually get into factoring this, we're always supposed to look for a greatest common factor first. So since I don't have a c value, both of my terms have a t, so I could factor a t out, and then I can see if there's a number that goes into -16 and positive 144, so what is 144 divided by 16? Well, it's 9. So I can pull out a 16 and a t, and my life would be a lot easier if I took the negative as well. So I don't even have to go through the factor box. I can just pull out a greatest common factor, which is -16t. Well, -16t squared divided by -16t is t. And 144t divided by -16t is -9. And by pulling out the greatest common factor in this problem, I no longer have a quadratic, so this is considered factored form. I don't have to go through the factor box. I do not have a quadratic left because both t's are only to the first power now. So this is factored form, and once I have in factored form, as long as I'm multiplying 2 things together and the final answer has to be 0, last week you worked on well, then either the first factor is 0 or the second factor has to be equal to 0. So now we're working on solving 2 linears. So I have to get t by itself in both of them by undoing my order of operations, and end up with 2 answers. One of them, t is 0, and the other one, t is 9. Well, at time 0 seconds, technically the ball is on the ground because this is where it starts, and it's starting on the ground. So this means the ball or object starts on the ground. And the other one, this means 9 seconds have passed. So in 9 seconds, the ball will hit the ground again. So that's going to be our final answer. The object hits the ground after 9 seconds. So even though I got 2 answers, the first one is the very beginning of time, so the ball's just starting on the ground. Second one is a positive 9, so the ball's going to hit the ground, or the object's going to hit the ground in 9 seconds. The last part then is you have to come up with a domain for the function. So our function we are working with is height of a thrown object is found by doing negative 16t squared plus 144t. So the domain would be all of the possible amounts of time that the ball could be in the air. Well, time starts at 0. And based on the work that we did, at 0 seconds, the ball will go up, come back down, and it hits the ground again at 9 seconds. So that will close off our domain. So you can use any numbers for time in here from 0 to 9 that will have the ball be in the air. Okay, on to number 6. Okay, this problem we had 2 tickets, one ticket and the next ticket, and their product was 156. So when we go to solve this, we would like it to be in standard form. So ax squared plus bx plus c, and we would like it to equal 0. And so right now, if you're thinking, well, it's in factored form, that's kind of true, except it doesn't equal 0, so we can't separate this and use the zero product property. We actually have to get it set equal to 0 first. So we'd want to distribute x, so we get 156 equals x squared plus x. And then we want to get it set equal to 0, so we would move the 156 to the other side. So now we have 0 equals x squared plus x minus 156. Now it's in standard form and it's set equal to 0. Now we can look at factoring it. So a is 1, b is 1, and c is negative 156. In the last problem, we were able to find a greatest common factor and pull it out to the front, and then we no longer had an x squared, or in that case it was t, and we were done with our factoring. This time we do have a c value, so we can't pull out an x, and the greatest common factor of 1, 1, and negative 156 is 1, so there's no GCF to pull out. This time we will actually have to go through the factor box. So the upper left hand corner is your ax squared, the bottom right hand corner is your c value, and to get the other two corners you'll need your factor x. The top of your x comes from your a value times your c value, so negative 156, and the bottom of your x is your b value, so 1. So we are looking for two numbers that multiply to negative 156 but add to 1. Probably you're not well versed in your multiples or your factors of 156. So we got 1 in 156, 2 in 78, 3 in 52, 4 and 39. Don't have to worry about 5 because it doesn't end in a 5 or a 0. 6 and 26. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10's not going to work. 11 doesn't work. And we end up with 12 and 13, and that's the end of our list because it wraps around on top of itself. Then we have to worry about negatives, so multiply to a negative, so one of our numbers have to be negative, but we're adding to a positive, so it's the smaller number that's our negative. And our final combination that will work then, two numbers that multiply to negative 156 but add to 1 are negative 12 and 13. So we plug them in, we have 13x and negative 12 x, and then we pull out the greatest common factor from every column and every row. So the GCF of x squared and negative 12x is x. The GCF of 13x and negative 156 is 13. The GCF of x squared and 13x is x, and negative 12x and negative 156 is negative 12, and you can always double check it by remultiplying. So x times x is x squared, 13 times x is 13x, x times negative 12 is negative 12x, negative 12 times 13 is negative 156. So in factored form then, we are talking about, I'll go over here, 0 equals x plus 13 times x minus 12. That's our equation in factored form. Now we can use the zero product property and split it up. So x plus 13 is 0, and x minus 12 is 0. Solve them. We end up with x is negative 13 and x is 12. Yes, we get two answers, but only one of them is our actual answer. So we can't have a negative ticket number, so that one's not going to work for us. So we are talking about ticket number 12. So the number that is being served right now is number 12. So the current ticket is 12. And they don't ask us for the next ticket, but we do have the ability to find it. If x is 12, then we could also plug 12 in for this x, and 12 plus 1 is 13, so the next ticket is 13. And yes, we already know that 13 comes after 12, but we should be able to use our expression to find that. So as you work through number 5, and it asks you to come up with the dimensions, so you'll have to get a width and a length. Whoops. You need a width and a length. Once you come up with your width, you can take that number and plug it in and do 2 times that plus 1, and you'll have your length. It's not necessarily the two numbers you get after you're done solving. Only one of these is my actual answer. Okay, the last thing we have to do then is come up with the domain. And in this case, we're not starting from a function, so we don't actually have a domain. But I guess if we want to think about this as a function, we're talking about the product of a number and the next number. So our domain would be all real numbers. You could use any number you wanted for x and be able to find its next number and multiply them together. So our domain is all real numbers in this case. Okay, you've got 4 problems to go solve and work to either email or upload. And I know this is kind of a long video, but hopefully those examples helped you out.